Hello students, we will start with the chapter Inside the Atom. Now you all have studied about matter. Matter is made up of very small particles. So what is an atom? So an atom is the smallest particle of an element which retain its chemical identity in all physical and chemical changes. An atom is the smallest unit of matter. Now, for example, if I break a chalk, the smallest particle that I can get, that is the atom, atom of the chalk. And when we combine all the atoms together, the chalk is formed. So, atom is the smallest unit of matter. Now, in this chapter, we will be studying about this atom, how this atom was discovered, who discovered it, and there are various scientists who gave their theories and they told that how atoms are there, what is there around the atom, what is there inside the atom. So all of this we will be studying in the chapter Inside the Atom. So the first scientist who put forth his theory was Dalton, and he gave Dalton atomic theory. Now what was the Dalton atomic theory? He told that matter is made up of atoms and atoms are indivisible and indestructible. You cannot divide the atom more. It is the smallest and the last particle. You cannot divide it. Also, he told that all atoms of elements are like different elements and they have different atoms with different mass. So he told that atoms may have different mass and different atoms will have different mass. He also told that atom is round, it is solid and it is like a sphere. So it is also called as ball. And this theory was proposed by John Dalton. Now he didn't told anything about what is there inside the atom, whether there are positive charge, negative charge, or what things are present inside. He just told that it is a round sphere, it is indestructible. So this theory was put forth by the scientist Dalton, and this theory is called as Dalton's atomic theory. Another researcher, Thomson, he gave his theory and he gave a plum pudding model. And according to Thomson's model, the positive charges is distributed throughout the atom. So inside the atom, there are positive charges and the negatively charged electrons are embedded in a gel of positive charges. So there is a gel of positive charge and negative charge electrons are embedded in it. This was put forth by Thomson and this was called as the plum pudding model. Now the distributed positive charge is balanced by the negative charge of the electrons. So both the charges are balanced and therefore the atoms become electrically neutral, he said. But again this was not readily accepted because he did not mention the exact things where the positive electrons should be there, where the negative electrons should be there, and something is there in between where it is. Nothing was explained. He just told that there are positive and negative charges. So from Thomson's plum pudding, it came to know that there are few charges which are present inside the atom. There are positive and negative charges which are present inside, but how they are present, that was not explained by Thomson. But his model was accepted that time, and then other scientists came who then told that more things are present inside the atom. Now, Thomson also compared his model to a watermelon. He said that the positive charge which is there, it is like the flesh of the watermelon. And we have seeds on the watermelon. So those seeds are the electrons. Those are the negative charge. So this was also told by him that the positive charge is the red part of the watermelon and the seeds which are there inside the watermelon, that are nothing but the electrons. So again, this was not accepted as he was not able to mention exact things about the atom. He just told about the charges. And he was also not able to say anything about the atomic masses, what mass is there, which is having greater mass. He was not able to say anything about that. Another scientist, that is Rutherford, he also studied about atoms, and he gave a Rutherford scattering experiment. He did an experiment, and what he took was, he took alpha particles. Now alpha particles are radioactive substance. So he took those alpha particles and he bombarded those alpha particles on a gold foil. Now there was a deflection screen on which he observed where those particles will go. So as soon as he bombarded those alpha particles on the gold foil, he saw that the rays of those alpha particles, they passed through the gold foil. But there were few which came back. Like here you can see these rays came back. So according to him, then he came to know that something is there in this gold foil, that because of which when these rays are going to it, it is coming back and few rays are going out. So then he studied more about it, and then he came to know that what is present in this thing, because of which the rays are coming back and it is not going through the gold foil. And then according to his experiment, he found out that an atom has tiny, dense, positively charged core that is called as nucleus. So inside the atom, there is positive charge which is present, that is called as the nucleus. So the thing which was there from which the rays were coming back, that was nothing but the nucleus, which was positive. As the rays were going, it was getting deflected from that nucleus. So then he confirmed that there is nucleus which is present. Then he also told that most of the mass of the atom is concentrated in the nucleus. So the maximum mass which is there, it is present inside the nucleus only. He also said that the electrons bear positive charge. They revolve around the nucleus in orbit. And he also told that the structure of an atom may be as a miniature like a solar system. The nucleus is like the sun and electrons are the planet. So the nucleus is the sun and electrons are the planet which is revolving around the nucleus. So this is what he then concluded through his experiment. But he did not say anything that how the electrons are revolving, in which orbits they are revolving. So this till Rutherford's time, these things were confirmed, that there is nucleus which is of positive charge, electrons are there which revolve around the nucleus. The fourth researcher was Niels Bohr, and he also told something about the atoms, and he studied in detail about atoms, and he then gave the orbits of the atom, and this is also called as the stable orbit atomic model, and we also say it as Bohr's atomic model. So Bohr studied the atoms in detail, and then he postulated that the electrons revolve around the atomic nucleus, which lie in the concentric circular orbits, which is at few distance from the nucleus. So there are different orbits in which the electrons revolve. The energy of an electron is constant, while that of its orbit, it is always constant around its orbit. When an electron jumps from an inner orbit to an outer orbit, it absorbs specific amount of energy. So whenever any electron is moving, it absorbs some energy. This was told by Bohr. The energy which is emitted or absorbed during these transition is equal to the energy difference between the initial state and the final state of the electron. So whenever you have to find how much amount of energy is there, so we need to find the difference between the initial stage and the final stage of the electron. So this was told by Bohr, and he also told that there is nucleus inside, there are electrons which are revolving around its orbits, and these orbits, they have few energy levels. That first will have different energy level, then other orbit will have different energy level, and so on. Now, how the electrons are distributed in an atom. So electrons revolve in a stable shell. These shells or the orbits, they have a definite energy. And the shell nearest, which is near to the nucleus, is called as the first shell. Then the other will be the second shell, third shell, and so on. The symbol, we give an symbol that is N, and is used as an ordinal number of the shell. So the shell is referred by the symbol like K, L, M, N. So the first shell which is there, it is called as K shell. Second shell is the L shell. Third shell is the M shell, and the fourth shell is the N shell. So we have four shells, that is K, L, M, N. And here we have positively charged nucleus. Now, how many electrons can be there in these shells? So, in the first shell, there are 2 electrons. In the second shell, we have 8 electrons. If there are 2 electrons, then only the shell is complete. And if 1 electron, it is called as incomplete shell. Then if it has 8 electrons, the shell is complete. Then third shell, it has 18 electrons, and then it continues like 32 and so on. So these are the shells. First, that is K, L, M and N shell.